Hello there! Today we are going to learn from where does the formula of the sphere 4 over 3 pi r cubed comes from. First of all, ubicate yourself in this notebook, where you can observe a sphere. Now, how can we calculate the volume of this three-dimensional figure? You can ask. Well, first, we need to remember a few statements. Let's start simple to know the area of a square. We know that we have to multiply the base times the height. This figure does not have volume because it is two-dimensional. But what about a cube, where not only is just about base and height, but also about y? Making an update in the formula, now the equation to find volume is equal length times y times height. Cubes are an example of a three-dimensional figure, just as spheres. But the sphere has a unique way to solve its volume, because for this figure you will need the volume of two more figures, cylinder and cone, according to a process described by Archimedes. Why? This drawing may help you out. Imagine the sphere with a radius r, then imagine a straight circular cylinder circumscribed to the initial sphere, with a height of 2r. And a base with a radius r. Finally, imagine a circular cone with a base of radius r, height r, and a 90 degrees vertex as it's shown in the drawing. These three figures described are necessary to explain the formula of the volume of the sphere. Now, to make this process easier, let's make an analogy. Let's think of the figures as recipients of water. Now, let's imagine these recipients are filled with water up to the same height, and let's call this height h. To these recipients, we want to add a very small quantity of water, so that the water in all recipients rises by the exact same distance, called d, in all three of them. This is like adding a very thin sheet of water with a thickness d. The volume of each sheet, represented by a V, is equal to the area A of the circle that defines it, multiplied by its thickness d. Each volume must be calculated separately, yet the thickness d will always stay the same, and should be as small as possible in order to have the smallest degree of error. Then, we can present the volume of all sheets with the following formula. Volume is equal area times d, and because every sheet is circular, then area is equal phi r to the square, meaning that volume is equal phi r to the square times d. Thus, we have to find the radius of each sheet, which are radius of the sheet of the sphere, RSP, radius of the sheet of the cone, RCO, and radius of the sheet of the cylinder, RCY. Now, we have to obtain each radius through the use of geometry. First, let's talk about the sphere. To get a volume of the sheet, we have to imagine an axis based on the diameter of the sphere. Then, at the height h from the ground, a perpendicular line establishes the radius of the sheet. Then, from the center of the sphere, a radius r is traced to the point where the radius of the sheet touches the circumference as shown in the drawing. As we can see, a rectangular triangle has been formed, and thus we can apply Pythagoras' theorem to obtain the radius of the sheet of the sphere with the following formula. Radius of a sphere to the square is equal r to the square minus times r minus h to the square. Now, to get the radius of the sheet of the cone, we have to do the following procedure. First, we have to trace the height r as an axis, and from it at distance h. We trace a perpendicular line until we reach a side. this line being the radius of the sheet of the cone. As we can see, two isosceles rectangular triangles have been formed one inside of the other one, and thus we can use the proportions to get the radius like this. Radius of a cone over r is equal r minus h over r. From we obtain the formula radius of a cone is equal r minus h. Finally, to obtain the radius of the sheet of the cylinder, we have to remember that the radius of the sheet is always the same independently of the height of said sheet. And thus, we get the following formula. R of a cylinder is equal R.
From these three results that give us the radius of the sheets of the figures, we can see a relationship, this relationship being represented by the following equation. Radius of the sphere to the square equals to radius of the cylinder to the square minus radius of the cone to the square. If we multiply all of the terms times pi to go from radius to areas, we can tell that the area of the sheet of the sphere is equal to the difference between the area of the sheet of the cylinder and the area of the sheet of the cone. Now, to go from area to volume, we have to multiply the areas times the thickness, d, and because this term remains constant, the relationship is constant as well. And because the sum of the volume of all of the sheets of a figure is equal to its volume, we can obtain the following formula. Volume of the sphere equals to volume of the cylinder minus volume of the cone. This theorem remains true by adding all of the sheets up until the vertex of the cone, or what is the midpoint of the sphere and the cylinder. And to reach the height of the sphere and the cylinder, we must place an inverted cone at the vertex of the existing one. Thus, for a formula that can be applied throughout the entire figure, we are left with the following. Volume of the sphere equals to volume of the cylinder minus 2 times the volume of the cone. Now, we can start with the substitution of the terms that we have in our theorem, in order to understand why we have 3/4 in our original formula. Volume of the cylinder equals to pi times radius to the square times 2 radius, area of the base times double of the height. Volume of the cone equals 1/3 pi times radius to the square times radius, a third part of the area of the base times the height. Substitutions in the theorem. Volume of the sphere equals pi times radius to the square times 2 radius minus 2 multiplied by 1/3 pi times radius to the square times radius, which translates to volume of the sphere equals to 2 pi radius to the cube minus 2/3 pi radius to the cube, or in other words, volume of the sphere equals to 4/3 pi radius to the cube. So finally, we can understand the reason why the formula is 4/3 pi radius to the cube, and it's because it has as base the volume of other two figures that have the same bidimensional figure, that is the circle, and the formulas for itself represent a relation between them, because they part from the same trigonometric explanation and from the same terms that are used in the formulas to obtain the area of and the height. With that being said, we have reached the end of the video. We hope the explanation was helpful and easy to understand, and that now that you can comprehend the reasoning behind the formula for the volume of the sphere. Thank you for your existence. You are very important. Don't forget it. Take care and have a nice day. These are the people that made this video possible.